In this video, we're going to discuss the units of temperature. So, if you live in the United States, one of the last places still using this is the Fahrenheit. So we'll see things like 80 degrees Fahrenheit. Most of the rest of the world still uses the Celsius system. This is the unit that most of us are familiar with when we think of metric. So degrees Celsius. Technically, that's not the actual metric unit. The real unit is the Kelvin. However, we'll see that Kelvin and Celsius are very closely linked. So how do we jump between them? What's different about these? Well, if we think of temperature, what we have is water freezes. So H2O freeze. And this is 32 degrees Fahrenheit and 0 degrees Celsius. That's perfect. They were both set so that would be true. And in terms of water boiling, 100 degrees Celsius versus 212 degrees Fahrenheit. Now, it might seem a little odd, but Fahrenheit was actually a pretty reasonable unit, or at least the original attempt for it was. They wanted a system, and they said, hey, water's a great constant, let's use that to compare everything to, which is what a lot of the metric system's based on. Granted, Fahrenheit tried to use 180 degrees to go between them. Old scientists love circles, and that's half a circle. Just what they were choosing. Because of the decimal system, we went for 100 degrees with Celsius system. But it was kind of the right idea. He said, hey, let's use the freezing point of water and the boiling point of water. Like, life is dependent on water. It's all around us. It's a good constant for reference. Problem was, they found the freezing point of pure water, and he said, you know what? I know water can get colder than this, because briny Arctic salt water is way below freezing. And so he went out of his way to find the coldest water that was still water. And really salty solutions can remain liquid despite being well below the freezing point of pure water. So he found that the coldest he could get was way down. It was 32 degrees up before he hit pure water, and that's why we're at 32 for the freezing point of water on the Fahrenheit system. So, right idea, got close, didn't quite get there. Well, if we want to jump between them, this raises a couple complicating factors. Conveniently, the size of a Fahrenheit and Celsius unit is perfectly defined. There is 180 degrees Fahrenheit for every 100 degrees Celsius. That doesn't mean their temperatures are equal, that means the size of the unit. Simplify this down, 1.8 to 1, or 9 degrees Fahrenheit, 5 degrees Celsius in terms of size. If the thermometer goes up by 5 Celsius, it will have gone up by 9 Fahrenheit. But the problem is, what is the real temperature? Because if you start at 0 Celsius and you go up to 5 Celsius, you are not at 9 Fahrenheit, you are at 41 Fahrenheit. So we need to be able to adjust between them. And the way that works, if I want to go from Fahrenheit to Celsius, you take your degrees Fahrenheit and you minus 32. This gets rid of that extra starting amount. It says, hey, set it to, go back to 0, get rid of that extra. Once you've done that, I can convert units. I can say, well, there are 9 degrees Fahrenheit in every 5 degrees Celsius. This will allow us to convert to degrees Celsius. So let's do an example here. Let's put in 80 degrees Fahrenheit. Well, minus 32, that's going to be 48 degrees Fahrenheit in size. So if it is 80 degrees Fahrenheit outside, that is 48 degrees above freezing. That is what we've just solved. Well, now we can say, oh, if it's 48 above freezing, now I can convert and find my Celsius, because Celsius is 0 at freezing. So 48 divided by 9 times 5 is going to be 666 repeating, but 26.7 degrees Celsius. So yeah, 80, especially for Washington, is pretty hot. 26 Celsius is where it gets pretty uncomfortable for me. Depending where you grew up, that might be wildly different, but I grew up here. Well, let's go from degrees Celsius to degrees Fahrenheit. You know, if you're in Canada and the weather report says outside that it is 30 degrees Celsius, how hot is that really going to be? Well, first step is to go backwards. So previously we'd subtracted 32 and then multiplied to find Celsius. I need to go in reverse. So for Celsius, I convert the Celsius into Fahrenheit. And then I go ahead and add the extra to get above that we require at freezing. And so I'll find this conversion is going to be 54 degrees Fahrenheit is the increase. There's 32 just being on freezing. And so collectively they are 86 degrees Fahrenheit. Which if we think earlier, we said 26-ish degrees Celsius was 80 Fahrenheit. So if I'm a little higher in Celsius, 30, I should be a little higher in Fahrenheit. And that's what we see. And so jumping between Fahrenheit and Celsius takes a little bit of extra steps because of that 32 at the freezing point for Fahrenheit. So what about Kelvin? Well, Kelvin stems from the fact that, let's go back on our temperature scale here. You know, at 100 degrees Celsius, water boiled. And at 0 degrees Celsius, water froze. But you can get colder. You can have negative Celsiuses. You can go down and down and down. But there's a limit. You can only go down so far before you hit the farthest you can get. There is a minimum temperature in the universe. There is an absolute zero. Well, we'll talk about it more in energy, but the basic idea is temperature is a measure of how much heat energy something is giving to another thing. So you hold a hot object, it transfers that energy into your hand feels hot. The idea is that if you don't transfer anything, well, that's the coldest you can be. Hotter things transfer more, colder things transfer less. Transferring 0, well, you can't transfer less than that. So there is a minimum possible temperature, which is nothing. That point is 0 Kelvin. And there's no degree symbol. A little degree circle we put on the other temperatures. That is to tell you that it is an adjusted system, that it's set at water. We don't do that for Kelvin. Well, how far down is this? This is minus 273.15 degrees Celsius. So you have to get really cold before you hit it. In fact, to date, nothing in the universe, as far as we're aware of, has ever reached absolute zero, and we don't think you actually can. But that's a quantum physics discussion. Nonetheless, we can get really close to it. In fact, the void of space shows up at about 2.73 Kelvin. Because there's just a little bit of starlight hitting things all the time, and light warms them up. The microwave background radiation left over from the Big Bang, things like that. There's just always a little bit of heat coming from places. Well, how do we then convert between Kelvin and Celsius? If I want to go from degrees Celsius to Kelvin, you take your degrees Celsius and you add 273.15. And honestly, in this course, we'll mostly just add 273. So if I had 10 degrees Celsius, I would add 273. It is 283 Kelvin. And the reverse is true for going from Kelvin to Celsius. Kelvin to degrees Celsius, you subtract. So if I have 300 Kelvin, I would subtract 273 to get my degrees Celsius, which in our case is going to be 27. And so jumping between Kelvin and Celsius is rather easy because there's no conversion. Remember that our Fahrenheit, between freezing, so 32 and 212 for Fahrenheit, there was 180 degrees. And between 0 and 100 for Celsius, there was 100 degrees. And so we had a ratio of 180 degrees Fahrenheit for every 100 degrees Celsius. Well, Kelvin, because it is still base for the metric, the size of 1 Kelvin is the size of 1 degrees Celsius. They're 1 to 1. They start at different locations, but this unit size is identical. If you increase your temperature by 10 degrees Kelvin, you have increased your temperature by 10 degrees Celsius. Celsius just sets 0 at a slightly different spot on the scale. And so it makes our conversions a little simpler than it is to go between Fahrenheit and Celsius.